What if everything we knew about the universe is wrong? A new space telescope hidden from headlines has just revealed ancient galaxies, invisible structures shaped by dark matter, and even rogue planets drifting in the void. Its name is Euclid, and in just its first glimpse of the cosmos, it may have rewritten the story of everything. This isn't science fiction, this is real, and it's only 1% complete. For decades, we've built telescopes to look deeper into space, searching for stars, galaxies, answers. But most of the universe isn't made of stars. It's made of something else, invisible, untouchable, and terrifyingly misunderstood. Now, for the first time, we have a telescope designed to not just see the cosmos, but to map its hidden structure, to reveal the dark matter web that holds reality together. In today's journey, we're diving into the first discoveries from Euclid, a telescope launched not to photograph beauty, but to uncover truths we've never been able to see. We'll explore how Euclid works, what it's already found, and why its mission might challenge everything we thought we knew about how the universe formed, expanded, and evolved. Galaxies that shouldn't exist. Rogue planets drifting alone. Patterns of matter shaped by forces we still don't fully understand. And here's the twist. What have we seen so far? Just a fragment, only 1% of what Euclid will uncover. Hidden beneath the noise of media headlines and celebrity gossip, a spacecraft quietly left Earth on July 1, 2023. Launched from Cape Canaveral aboard a Falcon 9 rocket, this spacecraft wasn't built to explore planets or even stars. Its purpose is far more ambitious: to map the structure of the universe itself. This is Euclid, a space telescope created by the European Space Agency with a single, almost impossible goal: to uncover the invisible. After a journey of 1.5 million kilometers, Euclid settled into orbit around Lagrange Point 2, a perfect pocket of balance between Earth and the Sun, where gravitational forces cancel out and the silence of space is absolute. It now orbits in quiet company, alongside the legendary James Webb and Gaia telescopes, but its mission is entirely unique. While Webb stares deep into the birth of stars, and Gaia charts the positions of nearby stars, Euclid is going after the dark side of the universe. Not in a poetic sense, literally the parts we can't see: dark matter, dark energy, cosmic voids, rogue objects. Euclid's mission is to chart a 3D map of the universe spanning over 2 billion galaxies and reconstruct how the universe has changed over time. But how can a telescope see something that's invisible? What kind of technology could possibly reveal the skeleton of the cosmos? To answer that, we need to look under the hood at how Euclid actually works, and what makes it so powerful, even compared to giants like James Webb. You might be wondering, how can a machine built by humans see something we've never seen before? The answer lies in how Euclid was designed, not as just another space telescope, but as a cosmic detective. While most telescopes zoom in on small corners of the sky, Euclid is built to see the big picture. Literally. Its powerful, wide-angle lens lets it scan massive regions of space in one shot, with enough resolution to capture not just galaxies, but the subtle shapes of galaxies distorted by unseen forces. What forces? Dark matter. You see, dark matter doesn't emit light, but it bends it. As light from distant galaxies travels through space, it curves around invisible clumps of mass like a lens. This effect, called gravitational lensing, is the key to mapping what we can't see, and Euclid is built to detect those tiny warps across billions of galaxies. But that's just one part of its power. Inside Euclid are two advanced instruments working in perfect sync. VIS, the Visible Imaging System. It captures ultra-sharp images in visible light, allowing scientists to measure galaxy shapes with pinpoint precision. NISP, the Near-Infrared Spectrometer and Photometer. This one looks at light we can't see, measuring redshift, or how fast galaxies are moving away from us. In other words, it places galaxies not just in space, but in time. Together, these instruments allow Euclid to do something no other telescope has ever done at this scale: build a 3D map of the universe across 10 billion years of cosmic history. And here's the crazy part. Euclid is so sensitive, it can spot objects hundreds of times fainter than what we've ever been able to see before. Some of these objects might be ghost galaxies, dead stars, or even planets with no suns drifting alone in the darkness. So now that you know how Euclid sees the unseen, it's time to take a look at what it found. And believe me, its first images are already changing what we thought we knew about the structure of the cosmos. Let's take a look at the very first snapshot of a universe we've never seen before. When Euclid first opened its eye to the cosmos, what it saw wasn't just stars. It was a puzzle. Between March 25th and April 8th, 2024, in just 2 weeks, Euclid captured 260 high-resolution images of deep space. At first glance, they looked like beautiful photos of distant galaxies. But when scientists began to piece them together, they realized something remarkable. They were looking at a cosmic mosaic, a stitched-together view of the universe so detailed, so massive, it covered an area 500 times the size of the full moon in the night sky. Inside this mosaic, millions of galaxies, some born shortly after the Big Bang, star clusters, nebula, and vast voids where almost nothing exists. Entire cosmic structures, all visible in one image, and in stunning clarity. And yet, this breathtaking view is only 1% of the final map Euclid will create. What makes this even more mind-blowing is the dual scale of the images. You can zoom out and see the architecture of the cosmos, or zoom in to spot individual galaxies, clusters, even gravitational distortions in the light. Imagine looking at a photo of the entire Earth and also being able to see the ants crawling across the sidewalk. That's what Euclid is doing, but on a universal scale. And hidden within this cosmic tapestry were discoveries no one expected, galaxies we've never seen, entire regions of space that were once invisible, and mysterious patterns of light that suggest something far more complex is at work beneath the surface of the universe. But to truly understand what makes this mission revolutionary, we need to go deeper into that mosaic and explore what Euclid uncovered, one image at a time. Let's start with one of the largest and most mysterious structures in the known universe, the Perseus Cluster. Among Euclid's first images, one stood out, a colossal gathering of galaxies known as the Perseus Cluster. It sits 240 million light-years away, and yet Euclid captured it in breathtaking detail. Over 1,000 galaxies in the cluster, and more than 100,000 scattered beyond. But the true surprise? Hidden among the giants were 630 dwarf galaxies we'd never seen before. Tiny, faint, and long overlooked, they reveal something deeper: the invisible pull of dark matter, shaping how galaxies form and where they gather. This isn't just a picture, it's a map of the unseen forces that hold the universe together. And if that wasn't strange enough, Euclid's next target is even more mysterious: a galaxy frozen in time, filled with ancient stars and secrets from the early universe. Floating just 1.6 million light-years from Earth, NGC 6822 is no ordinary galaxy. It's irregular, ancient, and nearly untouched by time. Inside, Euclid found stars with almost no metals, the kind that existed when the universe was young, before heavier elements were even born. But that's not all. Hidden in its wide field, Euclid revealed glowing star nurseries, H2 regions, and entire star clusters we never knew were there. It's like looking into a fossil of the cosmos, frozen mid-creation. But if you think that's incredible, wait until you see what Euclid found in a star cluster much closer to home, a place where ancient stars are packed tighter than anywhere else. In a quiet corner of sky just 7,800 light-years away lies NGC 6397, one of the closest globular clusters to Earth. a dense sphere of stars like a cosmic city where ancient suns compete for space and light. Until now, we could only see its bright core. But Euclid changed all that. In just 1 hour, it captured the entire cluster, including its faintest stars, the ones that hold clues to the Milky Way's oldest secrets. It's not just a beautiful image, it's a time capsule, glowing in the darkness. But what if there were entire galaxies we've never seen? Not because they're far away, but because they've been hidden behind our own. Imagine a galaxy almost identical to our Milky Way, but completely hidden behind a veil of dust and stars. That's Caldwell 5, also known as the Hidden Galaxy. For decades, it remained a blurry ghost in our telescopes, but with Euclid's infrared vision, that veil vanished, revealing spiral arms, dust lanes, and the complex structure of a galaxy that mirrors our own. It's like looking at a reflection of the Milky Way from the outside, but just beyond it, Euclid turned towards something even more iconic and mysterious. A swirling cloud where stars are born and planets drift alone through the dark. Just 1,375 light-years away, a dark shape rises from glowing gas like a cosmic sculpture. This is the Horsehead Nebula, one of the most iconic star-forming regions in the sky. But Euclid captured it like never before. In just 1 hour, it revealed not only the vibrant clouds and newborn stars, but also free-floating planets, massive worlds drifting through space with no star to orbit. One of them, S Ori 62, is 10 times the mass of Jupiter and completely alone. What else is hiding in the darkness? Euclid is only getting started, and the discoveries so far are just the beginning. Let's take one final step back and understand why all of this changes everything we thought we knew about the universe. Euclid hasn't just taken beautiful pictures. It's begun to rewrite our understanding of the universe. In just 1% of its mission, it uncovered hidden galaxies, ancient stars, and the invisible web of dark matter tying it all together. It's not just mapping space, it's revealing what reality is truly made of. And with 5.5 years still to go, the real surprises haven't even started. Somewhere out there in the silent dark, Euclid is still watching. And what it sees next might be even stranger than we can imagine. So if you think this was fascinating, just wait until you see what's coming next. This video will burn your mind. Don't lose it.